All right, let's get started. So this is the last session of build. You guys are happy that in 60 minutes it will be over? All right, you made it. I think we should clap for each one of you. Thank you. Okay, so we have about 60 minutes and ton of content. You know, I'm kind of an optimization guy, so we have a 60 minutes, and you guys paid full price for the build. So let's get everything that we can get out of this session in next 60 minutes. So we have some good content, and we'll go through it very, very quickly. So from a sessions perspective, I'm a program manager on Azure HDInsight. It is one of the largest big data cluster service in Azure. And we have thousands of customers running these big data applications using technologies such as Spark, Hive, Kafka, and HBase. And so what I thought it would be a good idea for me to share, what do these customers sort of go through when they architect some of these big data applications? What are the decisions that they make? What are the trade-offs that they make? And kind of share with you. Again, there is nothing right and wrong. Some things might work for your scenario, other may not. But I just wanted to share the experiences that we have kind of gathered. And so again, it's all about customer journey and their pain points and how they made decisions that they made. So typically, if you think about the sort of a big data landscape, I think you guys are fairly you understand the Lambda pattern, right? And if we think about our customer base, either they would be building sort of a data lake using a Lambda framework, or they would be using parts of it. But I think for this talk, I think it will be good reference because we do see customers sort of using that and bits and parts of the Lambda architecture for building these big data solutions. So typically, there is something called hot path where you might be ingesting data from devices and sensors, right? And typically, in the case of HDInsight, people use Apache Kafka to ingest that data. Then once they have that data, they need to be able to do stream processing. Sometime, if you think about device data, it could be very verbose JSON. And at the very minimum, they don't need those 2,000 fields that this device is sending. You only need about 4 of them, right? So at the very minimum, they might be stripping down the data that they need. In the other instances, they might be sort of mixing that data with some of the other data on the fly, might be running sort of a machine learning on data in transit. So that's kind of a stream processing. And then they tend to store, sometime in a SQL store, but if it is a device data, typically it end up being a NoSQL store. In our case, a lot of people use Apache HBase or Phoenix, depending on their choice to store that. And then that kind of forms their serving layer. For the cold path analytics, where now you are storing all of this data, and not only you need to run analytics on a real-time basis, you also want to run that analytics on the historical basis as well, like you're trying to find patterns and things of that nature. And so you would typically also store the data in a data lake storage. On the batch processing side, typically you would get data from various line of business applications. These applications might be sitting on premises, or they might be sitting in the cloud. And then they would be ingesting data every minute, every hour, every day, every week, depending on their use case, and they'll be ETLing that data. And then they'll need to think about their governance. How should they think about the metadata management, security and access control, orchestration, as well as what we call like a serving layer. I think many of our customers basically run this analytics and put data into some kind of a data warehouse for like a BI reporting. But we are seeing more and more of a use case where data lake itself being used, a place from where you want to kind of open it up for entire organization, and they are able to then drive analytics directly from there. So we'll kind of talk about that as well. And so when customers look at this kind of a problem solving or this kind of architecture, there are a ton of sort of technologies in Azure, right? There is a data factory for orchestration, and there is Azure Data Bricks for Spark workloads, then SQL data warehouse, and so on and so forth. But today's focus is on HDinsight. I think that's where we're going to spend our time. Now, why do somebody pick HDinsight? There's so many things on that chart, right? And why do we see customer picking HDinsight? I think number one reason why they do it, because they want to preserve existing investments. So they may be running some of these big data technologies on premises. They might be using Hive, Pig, Storm, and it's just one-to-one translation, so they don't have to do that code again. They like a managed offering, because if they were doing this in an IaaS form factor, then responsibility of SLAs and managing and support and everything kind of lies on them. In HDinsight, I think it's a managed offering, so you get a lot of pieces. Then HDinsight is able to support multiple workloads. As we saw this Lambda architecture, there is no part of that architecture that is not supported, that is not supported by HDinsight, or we don't have there is no, they find all of those components, and all of those components sort of work together with each other as they are part of same platform. They want to keep same code base. Sometimes our customers tend to run these pieces in like Google, Amazon, their on-prem. And because we are using 100% Apache open source technologies to power some of these services, they don't have to change their code base quite a bit. Row and column level security, I think we'll talk about that. And then the low cost. If you look at how HDinsight is priced, it's literally at the price of virtual machine. And so we're very low cost big data provider in Azure. But anyways, so some of you are wondering, like, what is it, by the way? So HDinsight, just to talk very quickly, if you look at these open source technologies such as Hive, Kafka, Spark HBase, Storm, and few others, we just package them and deliver to our customers as a managed cluster form factor. So that's what it is. But even though they have decided that they want to go build something on HDinsight, but there are many questions that they need to answer. So for example, we talked about the stream processing in that Lambda architecture. Should we go with a Spark streaming or think about Storm? Or if we are thinking about our serving layer, a layer which will serve data to your data scientist or business analyst, should we use Presto, Hive LLAP, Spark SQL? Storage, again, in Azure, there are gazillion, multiple type of storage system. There is ADLS Gen 1, Gen 2, Blob Store, the premium Blob Store, and so on and so forth. And so how do we make that decision? How should we think about orchestration? Should we think about Azure Data Factory, or we should bring Airflow for our orchestration? Or we have been using Oozie on premises, and is that good enough? Or what should we use for ETL? So those are some of the questions that they need to kind of figure out. So let's start going through those questions and talk about some of the pros and cons and how people make the decision. First, let's get the easy one out of the way, right? So the ETL technology choice, Spark, Pig, and Hive, those are the three things that we see within our service. As you see from adoption perspective, Spark is getting quite a bit of adoption, whereas if you think about Pig, we have customers who may be running Pig on premises, but now they want to run the same system as it is in the cloud. They might be running it there, but literally nobody is building net new applications using Pig. Moreover, Pig is quite a bit of a slower than Spark. So if you are running something in Pig, then essentially you are paying more money because the performance is slower and you are spending quite a bit of resources there. So I think that piece is a lot of people, the people who are writing net new application decide to go with Spark. Hive, people do say that they do use it for ETL, but in reality, it's mostly around data warehousing side of it. Then streaming engine. Again, if you use Storm, or some of our customers who come from a Storm background, they swear by Storm. They really love it because of its low latency nature, because you can process a single event as it comes, right? You don't need to micro batch, anything like that. And then there are systems like that where it's very important for those systems to be able to process every single event as it comes, right? So Storm has been very popular in that sense, but now Spark has a lot of momentum, and because Spark is a general purpose framework, and they are doing ETL with Spark and other things with Spark, it kind of makes a natural sense to use same platform. It fits your need. But again, it's a micro batch based architecture. Again, you get a throughput because you're batching many events together. But understand that trade-off around a very low latency stream processing with singular events. The third one kind of becomes a little bit more complicated, which is interactive query technology choice. So at this point in time, what you have is you have established a lake, and in the lake, now you have a data in its rawest form, right? It could be text, JSON, or Parquet, and so on and so forth. And now what do you want to do? You want to expose this data lake to your broader organization. And so, in some use cases, you might be exposing it to a small team. So the Spark SQL might be, great fit because you're already using Spark for so many use cases. But as you tend to sort of expose it to more and more users, question around concurrency, resource governance, kind of become very, very important. So if you look at the Hive LLAP, which is an interactive query cluster, you could do some very sophisticated things such as high concurrency. I think we have a TPCDS result that talks about 64 concurrent queries there, so that becomes very important. Result caching is another very important area, because imagine you have hundreds of users submitting query to this cluster, and they are issuing same query. Now, everybody is interested in, or some of them are interested in like a same results. And if result is already available, why compute once more, right? And so the result caching, feature like result caching, where results are also cached if underlying data hasn't changed. They serve out results very, very fast. Two, they don't put any strain on the cluster because you're not doing any computation, right? So that becomes important. Other aspect is the materialized views. What slows you down in a big data is, the joins, right? Because you are doing computation, and that requires resources and time, and your end users who are expecting interactive queries results gets frustrated. And so materialized view is a technique long known as data warehousing world, where you can pre-compute your results ahead of time based on some time schedule or based on whether your source data has changed or not. That kind of speed up things quite a bit. Then the other aspect there is the transactions. Imagine, we talk about big data systems that, you write once, you read many times, you update never, and you delete never. That is not true in a practical life. There is bad data that sort of flows into your data lake. There are regulations like GDPR where you need to be able to delete that and individual customers' data. So you need to be able to do insert. You need to be able to do update and delete. The Hive LLAP has those transactional capability, and so on and so forth. Now, if you look at Presto is it's not as strong with respect to some of these concurrency on the concurrency side of it, as well as the scale side of it. Where it really shines. Imagine a scenario where you have a data in Oracle and the Azure SQL database and Hive and someplace else, but you want to write a single select query which goes against all of these data sources and bring data to you. So it's kind of a data aggregator in that sense. So it's been very, very popular with our customers because Presto have these connectors with all these different data sources, and people could do very sophisticated queries there. How about Metastore? How many of you have to deal with Metastores? Okay, so what is Metastore? So in big data world, there is data which is in data lake, right? But then metadata about that data is stored in Metastore, right? So that's the Metastore. So Hive Metastore is this glue that sort of binds all of these big data engines together, because if you look at Spark, it understands Hive Metastore for catalog. If you think about Presto, it also understands Hive catalog for metadata. If you look at Pig and some of these technologies, so it's a very critical component. And so to the version of HDinsight 3.6 and Hadoop 2.6, what was there was, you could basically have a single Metastore and single, like a data lake, but all of these engines can come via this Metastore and understand this data, right? Which is great. If you look from a concept perspective, it's amazing. But then if you double click on it and you think then every engine is trying to do this common minimum thing, right? And it may be good for sharing in some cases, but the engines cannot optimize from a performance perspective, from a transactions perspective, because again, all of them need to abide by a common minimum thing that a common Metastore can do. So what's happening with the Metastore now? Spark and Hive are sort of a primary participant in that Metastore. So the community is, Spark going to have its own Metastore, and Hive will have its own Metastore. So now these are two Metastores, and the way they talk to each other is via the Hive warehouse connector. So this is a Apache HBase implementation. It's in-memory data transfers quite fast. Now, the implication of that, the benefit of that, right? So earlier, if you were using transactional data in Hive, Spark couldn't read that data, couldn't do anything with that data. Only thing it could do was corrupt that data because it didn't understand that data, right? But because of now it's going via a supported and compatible compliant mechanism via Hive warehouse connector, all of a sudden Spark can read and deal with Hive's transactional data, for example. So these are some of the benefits that sort of comes with this architecture. But again, if you are building a data lake system with the latest open source technologies, you need to kind of understand this difference. And then the data pipeline orchestration technology choices. If you are in Azure, you're probably very familiar with Azure Data Factory, which is the PaaS solution. A lot of our customers actually use Azure Data Factory. Then there is Airflow and Oozie. So as you can see, Airflow is an open source project initially contributed by Airbnb. And it has a lot of momentum with it. So if you look at the stars on it, it's 12,133 stars as I counted last night. So there is a huge momentum with respect to that. If you are building sort of a multi-cloud solutions that you need to deploy on-prem, other places, Airflow could be a good choice, and a lot of our customers sort of use that. Oozie is something being a traditional orchestrator in a big data Hadoop world. As you can see, its popularity is kind of going down. But again, if you've already invested in Oozie, you could bring it along. But I don't think this is the time to build a net new sort of Oozie application for a brand new application. Right? All right, so I'll probably take a couple of questions there. All right. No question, we save time. Let's move on. Okay, so once you kind of decide this high level, like what technologies are you going to pick, the next big question in front of you would be storage, right? If you are building net new application, that is great. But if you already have hundreds of terabytes and petabytes sitting in some kind of a Hadoop implementation on premises, you need to think about how should I move that data to Azure. Then in Azure, you have so many different storage options. What should I pick and what are the trade-offs? And again, any one of the storage options that you pick, these going to be remote, right? The storage is always remote. It's few milliseconds away. And so the caching techniques in cloud becomes very, very important, and we'll talk a little bit about that as well. So if imagine you have 2 petabytes of data on-prem, and you had a 45 megabit per second link, and you needed to transfer that data to Azure, it will take you 12 years, right? So that's the reality of it. Then big data transfers are tricky, on wire, right? And so again, if you have a smaller data set, you can of course use ExpressRoute, any of the tools, those are available there. But if you have a very large data set then you need to move to Azure. There is a data box. I don't know how many of you are familiar with the data box. Right, great, good deal. And so the data box, and we've been working with the data box team for quite some time. They actually wrote at the bottom of there is a link that actually takes you to a step-by-step guide in terms of how this appliance would work. So we basically ship these devices to you, and then there are a set of instructions that you need to follow, and then you can offload your data into Data Box. Then it gets shipped back to Azure, gets plugged in, and your data becomes available in Azure Blob Store. So, if you have a lot of data, use that option. Now, once you move your data, then ADLS Gen 2, standard blob storage, premium blob storage, premium managed disk, ADLS Gen 1, how should we think about what should we pick? So if the blob has been there forever, right? It launched with Azure. So it's very mature technology. It's battle tested. It has seen good and bad days, but it certainly lacks from a feature perspective when you think about big data applications, right? So for example, one simple operation, one simple operation that happens in a big data world is called atomic rename. Have you guys heard of that term, atomic rename? So when the map reduce is happening, when you have a distributed computing and the Spark executors are on different nodes, trying to crunch the local data, and as the intermediate results comes back, they got put into something called temporary folder, right? And when all of the results are computed, then that temporary folder is renamed as an output folder, right? Renaming of that temporary folder to output folder is a metadata operation. No actual file moves anywhere. It's just a metadata operation, right? You just change the name of the folder. But Blob does not have file and folder mechanism. So when this thing happens, you're basically moving data from one container to other container. It's actually a physical move of a file. So it basically slows down your ETL pieces, right? Although we have done quite a bit of work, we run 128 threads to move that data, but again, it is not as good as just a metadata data operation. So I think recommendation pattern is for all of your analytics, big data type workload, we should use ADLS Gen 2. It works pretty well. We're trying to transition all of ADLS Gen 1 customers to ADLS Gen 2, so no point building for ADLS Gen 1 at this point in time. These premium blob storage are important, so I'll kind of talk about that now. So I talked about this idea of you have quite a bit of bandwidth. With bigger nodes, you can get tens of gigabyte per second type bandwidth with underlying storage, right? And so if you have a workload that reads a lot of data and writes a lot of data, which is great because then you can sort of batch that data. We actually batch it behind the scene, and thereby, your performance is very good because you have high bandwidth. But one of the challenges that comes in is with like low latency type workloads, such as in NoSQL workloads such as HBase or maybe Spark streaming or a Storm, where you need to be able to write very, very fast because it's a low latency workload. And your storage is sitting 20 to 200 milliseconds away. So how are you going to kind of do that? So I'm going to kind of talk about one of the use cases, which is HBase. So how many of you understand how HBase works? Okay, few people. Okay, so let me explain now for the folks who have not had a chance to look at HBase. So in HBase is a NoSQL store, and all of your data is stored in a sorted order, right? And so it's very good for high throughput writing and point reads, right? That's what its use case is. And so in HBase, all of these clusters are cluster nodes are known as region servers, right? You can have multiple nodes and multiple region servers. So we are looking at one of them. Each region server can have multiple regions, right? In this case, I'm just depicting 3 of them. And then these region nodes has in memory. They have like a memory. So when you write something, data is actually written to these, where I say Metastore H files. That's where the data is written. It is written in memory. So it's great. It's very fast because you're writing in memory. And then after a certain threshold, let's say you had a threshold of when my data there reaches, let's say 128 megabyte, then you flush that data to underlying store, right? And so your write path is very, very fast because you are committing to your storage later. But what happens any one of these nodes go down, right? All of your data will be lost. And so the way HBase sort of protects with this node failure thing is by implementing something called write-ahead log, where, okay, it will write to these in-memory structure in a highly decorated fashion so that if there is a read is coming, you could actually serve that read out of, from Metastore itself. But then I would also write a log to the underlying storage so that if this were to go down, I can recreate my data, right? So that's the whole purpose of write-ahead log. So then if you look at the operations there on the write-ahead log side, if you did the insert, update, get, and delete, it needs to happen in a synchronous order, right? So you cannot do delete. You cannot do delete before insert happens. So insert needs to happen first, update, get, and delete. But what you see with any kind of a remote storage is that for a vast amount of time, you'll see very good latencies, like 9 milliseconds, 10 milliseconds, 8 milliseconds. But all of a sudden, you'll see these 200, 300, 500, 700 millisecond spikes. And all of your writes sort of, are blocked behind that one big latency episode because it's synchronous in nature. And so then, so what we do for those kind of workload, we introduce the premium managed disk, right? So in this case, instead of writing that to the blob store or Azure Data Lake Storage Generation 2, we basically write that wall into a premium managed disk, which is attached to the cluster, right? And so then, your writes are very, very fast. They are astronomically fast, right? So we see, the great performance just by making those intelligent changes. Now, we're still putting your data in storage, but the way we have kind of thought about, just thinking about these problems in the architecture, and that's what a lot of our customers use. So if you are using HBase, there are two flavors with a standard storage, and then other one that we recently released is with what we call accelerated write, where we put a premium managed disks on the nodes so that your writes are very, very fast. Now you would say, how about reads? You could have some workloads where you may need a latency in a single millisecond digits, right? So we have also started supporting premium blob storage. Again, it's a blob store, but it's built on SSD. So if you put your data into the premium blob store instead of a regular blob store, you're going to get very fast latencies. Questions? Right. So far, good? Okay, good deal. So again, so we talked about these techniques, local versus remote. But how should you think about the more cheaper storage, which is again a remote store, and making it faster? So the caching techniques becomes very, very important. And there are multiple different workloads, and there are multiple different caching techniques. So for Spark, we do Spark. We call it Spark IO cache. It is based upon Rubik's cache, which is an Apache project. So what happens is that if you're reading something from Spark, it is cached locally, and then if you are issuing same query or other query that need data which is locally available, then it can be very, very fast. In HBase and Phoenix, apart from all the things that I talked about, HBase natively have something called bucket caching. So again, recently written data, recently read data would be put on your L2 cache, and thereby you can serve that data from cache directly, thereby giving this illusion to the end user that it's very, very fast. If you are looking at Hive LLAP in terms of your serving layer, it has something called intelligent cache, where all of the data is again cached into the local memory. And when I say local memory, there are two parts to it, right? One is your dynamic RAM, and then other one is the local SSD. So for example, if you were creating one of the Hive LLAP cluster with, let's say, D14 V2 VM type, which is a VM type, it has about 800 gigabyte of local SSD, right? Free, no charge. I guess it is bundled in, but that's what it is. And so then between RAM and SSD and remote store, the engine itself takes care of how do we recycle the bits and everything. So it's very, very useful in those cases. So do consider sort of using these options when you kind of build these options. So this is the HDinsight IO cache. You just activate it, and then you get the caching. Here at the bottom is the TPCDS run on, I think, 1 terabyte scale. Again, in TPCDS, the benchmark derived from TPCDS, not every query responds favorably to caching, right? Sometimes the caching may not work. But even then, if you run the full workload, it's about 2x faster. But there are several queries, about 20 plus queries in TPCDS derived benchmark, where it is about 8 to 10x more faster, from a performance perspective. So the queries where you could, like a repeat queries, that's where you're going to see a lot of pieces. Security. There is a question. Yes, we have, but we're not allowed to share the numbers. A good question, though. Okay, all right. So let's talk about from a security. I think this is as in it's a data architect session, but the security is always top in mind for everybody. So the way we think about security, parameter security, you need to think about authentication, authorization, and data protection. From a parameter perspective, you can put this cluster inside a very secure virtual network. That information is out there quite a bit. For authentication and authorization, we depend upon Azure Active Directory infrastructure, and I'll talk about that a little bit more. For authorization, it is Apache Ranger, along with the ACLs that you could do on ADLS Gen 1 or Gen 2. We'll talk about that as well. And data protection is, your data is encrypted while it is in transit or while it is stored. So all of those pieces are there. So I want to kind of just explain this diagram because it's a little bit complicated. So if you look at the open source technologies that we talked about, like Spark, Hive, and HBase and others, in open source, from a protocol perspective, all of them work on a Kerberos, all right? So the Kerberos is the protocol. But if you look at Azure Active Directory, which is your identity store in the cloud, is OAuth base. So these are two different protocols, right? So then what that means is it is not as easy as just pointing your cluster to Azure Active Directory and things will work. They don't, because they're different protocols. So then what happens, we use a component of Azure Active Directory called Azure Active Directory Domain Services. It is basically the domain services instance. And so we basically sync the user identities from Azure Active Directory to this, the domain services. And then it basically acts as a server that can then issue these Kerberos tickets to our cluster, right? So it's a little bit of a complicated setup, but it works. So let's look at the little bit of a demo in terms of how, once you go through this setup and how it sort of works and what can you do with it. So in this case, I have a cluster. I'm sorry, let me switch. You guys can see it. So I have a cluster, and what you see right now, this is Ambari. How many of you are familiar with Ambari? Okay, quite a bit of you. So this is a cluster manager. It does few things such as monitoring, configuration management, service management, and so on and so forth. And it also provides certain tools to do few things. So for example, one of the things it provides is a tool called Hive View, where you can basically write Hive queries against the data in the data lake. Now, I talked about this authorization component, which is Apache Ranger. As you can see there, this is Apache Ranger, and Apache Ranger has a lot of different plugins for a lot of different things. In this case, we're going to look into this plugin called Hive plugin. And what I can do here is I can define my Hive access policies right here. So just click on this one. So one of the policies that I actually have a table called Hive sample table. It's a default table that comes with our cluster. And so on this Hive sample table, what I want to be able to do, I want to mask some data because I don't want a certain user to kind of see this data. So I could show you like what I've done here. So I named it like a Spark policy. Here is your table. And for this column within that table called client ID, for this user Ashish TH, and this is your domain user. This is the user which is there in your Azure Active Directory. I want to be able to redact that data, right? So I don't want Ashish to see this client ID from this table, as simple as that. So now if Ashish comes here and runs this query here, and as you can see, I'm logged in as Ashish TH here. It executes, it brings the data, and as you can see, this client ID is sort of a redacted, right? Now, there is a other user here, and her name is Alice, as you can see here. Let me make it a little bigger. So this is Alice, and as you can see in that policy, I did not mention Alice. Alice had like all of the access, and now Alice is running the same query select star from Hive sample table, and now you can see that she can actually see the actual data right there, right? So again, this data is in data lake, right? This is not in, these are the raw text files sitting in a Azure Data Lake storage generation 2. And now you are able to do column level security in terms of which user can see what data from those CSV files that are sitting down there. So that's very powerful. Now so this was just a Hive operations, and of course you expect us, Hive to respect a lot of these pieces. But any one of you could SSH into the machine, and you want to be able to access that underlying data storage directly. How does that work, right? How does these identities get propagated to underlying store? So let's do that. Let's look at that. So I want to look at the Azure Storage Explorer. So here is the Azure Storage Explorer. And within that, I have this folder called test, as you can see there. And if I look at the manage access, so here is the manage access thing. And as you can see, Ashish TH at Secure Hadoop on Microsoft.com has read, write, and execute access, on this person, on this folder. But you don't see Alice in there, right? Alice has no access on actual folder on the Azure storage side. This is what I'm showing you, the actual storage. So now this user, let's say, in this case, Ashish, SSH into the cluster node. So this is my SSH, and I'm SSH into one of the cluster nodes. And from there, I'm going to do HDFS commands on this ADLS Gen 2 thing. So now I'm ABFS : here is my container, and I want to kind of browse the content of that test folder. So I'll just hit enter. And it says, the 2 records found. So it's, because I had that, you saw that Ashish TH had access on that underlying storage. The identity, we were able to pass the identity from cluster all the way to underlying storage, and that got respected. Now, if Alice were doing same thing again, and you saw Alice had no permissions there, and she runs the same command again. She want to browse like a test folder, and hit enter, and she should see 403 request denied because she doesn't have a permission. Now, if I add Alice back there, she will have the permission. So what I'm saying is that you could also set these permissions at just the data lake itself, and your user identities would flow from cluster to underlying store, and they'll be respected. This is very useful in scenarios where you are mounting multiple cluster against same data lake, right? And so you could have your permissions at the underlying storage level, and then let people do whatever engine that they may like, in your organization. So that's the good part about it. Okay, so now we just saw two things, and it may have confused some of you. So there are now two authorizing engines in the scheme, right? There was a Apache Ranger, and then there were access controls from ADLS Gen 2, which would apply and when, right? So here is a little table for you. So if we think about some application level actions, such as you are doing a Hive query to get the data from Hive, or a Spark query to get the data from Spark using the Hive Metastore. In those cases, the Hive plugin, or in the case of Yan plugin, they become the authorizer, right? So that's the piece. But let's say you are creating a Hive table, and in Hive table you write your schema, but then you also tell a location, in terms of where your data is. So when you write that statement, you are basically pointing to a location within the storage, right? In that case, you gotta have a permission in both places. You need to have in Ranger, and you need to have in underlying store. Or if you think about like a Spark data frame API, or a Spark RDD API, where you are doing, you're reading a CSV file in some storage location, and if you don't have a permission, you'll get access denied, right? So in all of these scenarios, wherever you are directly referring to the storage, then at the minimum, you must have the permission at the storage level, and then you also need to have a permission at the Ranger level and a different plugins in there. All right, any questions? Okay, good deal. Resiliency. I think this is, we don't talk much about these pieces, but I think we should. A lot of things can go wrong, right? So let's say, you are, you have a system where, you build a lot of clusters every single day, and you process things and then tear them down, or you scale up and scale down. If you look at the HDInsight cluster, it is made up of a bunch of Azure services. There is load balancer, there are VMs, storage, and you name it, we use it, right? And on top of that, there are multiple open source frameworks that we wire up to build this cluster. Things can go wrong, if any one of the component go. If you have a system where you have so many components, your reliability is the minimum of the most unreliable, maximum of the most unreliable component, right? That's what it comes down to. So account for the failures, right? You are creating clusters. Once in a while, there would be a cluster that would fail to come up. Implement retry logic. Same is with your manual scale up and scale down. When you scale down, and sometimes this happens quite a bit. So let's say you are running something, and you have some data in a local HDFS, and you were running this, let's say, 100 node cluster, and now you shrink that cluster all the way back to, let's say, 3 node cluster, or a 4 node cluster, or a 1 node cluster, right? So we do node decommissioning. So node will get decommissioned, the one that you have deleted or scaled down, and then the local data gets replicated on remaining nodes, right? But if it is a drastic scale down, that 1 or 2 nodes may not have enough space for all of that data that is sitting across a lot of those nodes, and cluster can get into something we call like a name node getting in a safe mode, right? It doesn't understand. It's like, where is my data? I'm panicking. And so there are a few manual steps that you could do that I've listed there in order to bring cluster out of that, the safe name node getting into the safe mode. Other thing that we if you are doing a scale up and scale down to save cost, at the build we announced auto scale. So you could leave your scaling of your cluster to us, and based on a load or a schedule, we can scale down your cluster. It's a graceful scale down, so we wouldn't drastically scale down your cluster from 100 to 1 node, because we know that that would get you into the trouble. So we do it in a graceful fashion. And so the way you do it, you just set up, as you can see here, you could say that, hey, whether I want a load-based or a time-based. And then if you say time-based, then you schedule a specific time when you want cluster to be scaled down. And then you can monitor, how your scaling operations kind of happening. So this is a much cleaner option because, we do it very thoughtfully, very purposefully, and you'll be in less trouble. Okay, now your cluster is up and running, and you've dealt with cluster creation failures and scaling up and scale down failures. So the way we build cluster, we built in a high availability mode. Again, there are so many different components, and any component can go down at any point in time. So there is a built-in resiliency in a sense that all of our master services run in like a 2 master nodes. So even if one master node were to go down, there is another master node that then takes over, and your jobs are not impacted. If a actual worker node goes down, then of course it probably take more time for your job to complete because that node has gone down, but your job won't be impacted by that. So there is a level of resiliency sort of a built-in, and things do, in a distributed system, things do go wrong, right? So don't get alarmed with that because things are meant to go wrong, and a system is built in a way where your system won't be impacted. However, catastrophic failure can happen. The whole data center can go down. There could be like a storage outage or a network outage, and those kind of things can happen. And if you have like a more sensitive application, plan for disaster recovery, right? There are certain options for like a Spark and Hive. There are a bunch of ways you could do disaster recovery. I've actually had some resources there. We basically walk you through a lab in terms of how to set it up. So those resources are down there. For Kafka, a lot of our customers use Mirror Maker. For HBase, they rely on HBase replication, import, export, and things of that nature. So again, this is a topic in itself. I can probably spend hour just talking about DR, but I recommend going through some of this material and making yourself familiar with that. Last is monitoring. But before I talk about monitoring, any questions? Okay, great. So the question is, what is the state of autoscale? And if there is a running cluster, what do we do? Can we apply it to a running cluster? So the question, answer to your first question is that it's in a public preview right now that we announced at Build. So anybody can go ahead and try it out. It is not available on existing running clusters. You'll have to recreate a cluster, and then you'll see autoscale options with that. Monitoring, okay. So monitoring, not a lot of people think very deeply about it while they're building the solution, right? When they put it in a production and bad things happen, then people are like, how do I monitor? How do I better monitor? So there are multiple options. The first one is Apache Embody, which comes by default with a cluster. And so with every cluster, there is some monitoring. With Embody, you could do infrastructure monitoring, so you could see how your compute and memory and all of those pieces are doing. Embody also lets you launch various other monitoring tools. So for example, there is a Tez view to look at your Hive jobs and what is happening with that. It lets you launch a Spark history server so that you could see what's happening with your Spark. It lets you launch HMaster UI for you to see what's happening with your HBase. So this, that is a tool. But the problem with Embody is that it's a very cluster specific. Its life cycle is tied to the cluster. But if you look at the cloud, 80% of our clusters don't see a second day. People bring them up, do computation, analysis, and then tear them down. But if they want to look at some log, they want to look at that Spark job log, but the cluster is already gone. How do you do that? So Embody is again amazing tool if you have a cluster that is alive and running, right? It's not a really good tool once the cluster is deleted, or you have a topology where you are maybe doing hundreds of clusters. How many different Embody UIs that you need to go. And so what we have there, we actually have an integration with something called Azure Log Analytics, which a lot of our customers basically use. And so they basically hook up these clusters to the Azure Log Analytics, and we expose all of the system counters, such as CPU, memory, that kind of performance counters, that kind of data. We also expose all of these open source application related data, such as the Spark job or a Hive job related data. If you are running Zeppelin, Jupyter, the log data related to that. If you're running HBase, then all of the 900 plus metrics that HBase exposes, we put it in log analytics. And good thing there is that you can set up alerting and understand if there is some issues happening in your environment. Now, again, log analytics in Azure is a generic solution. It is not purpose built for these big data applications, right? It's a general purpose monitoring tool. And sometime what would happen is, you may get that alert in log analytics first, but then you are going to Ambari to see, how things are happening in a way where it makes sense from a big data perspective. Other place it is very useful is log search, because typically if you look at the big data system, you basically SSH into a node and then understand what's happening from a logs perspective. But now, because logs are in this one place, which is log analytics, you could do very sophisticated query correlation between logs and so on and so forth. So it becomes troubleshooting way easier. And then we also use Azure Monitor to expose certain metrics as well. But I think for your production use, Ambari and log analytics going to be great fit. Some customers have other tools. They might use Datadog, for example, or they may use Splunk. That's what they use for monitoring. They are more than welcome to install the agents from those tools on HDInsight cluster and kind of monitor in that fashion. That's about it. Thank you. Yeah, so the question is, hey, on the a Spark side of it, what kind of a problem that we see and all of that. Again, it's a very wide area, and happy to talk offline. But there are infrastructure related issues. How you think about cluster creation, its reliability. So that's one set of issues. In terms of running job on a data, that relate to your data partition, file formats. Bucketing or no bucketing, those kind of decisions. Whether you have a data skew, whether you have a time skew, is there a UDF that is taking more time or less time, right? Those type of issues. Then monitoring related issues. If you are running a job, how do you think about how it is progressing? Because if you look at the Spark history server, for example, you only get a data once a job is finished. You don't tend to understand what is happening in between, right? So those would be some of the pieces. But if you have a specific use case, happy to chat with you offline and talk about that.
So HDInsight spins up its own VNet, right? So the controller unit for HDInsight resides outside the VNet because it needs outbound connectivity to the internet. So has that been resolved? Because I know that there's a VNet injection available for Databricks, but for HDInsight that's still not available.
So,
security vulnerability from an enterprise standpoint.
So I'd like to understand that a little bit more. I think the way we put it, when you create a HDInsight cluster, it is actually put in your own subscription, right, or your own virtual network. Then HDInsight, because HDInsight need to manage this cluster, it needs to see whether it is, first it needs to create that cluster, and once it has created, it needs to be able to monitor and manage that cluster. For that, we do need access. And so there are 6 IP addresses that we advertise that you should whitelist so that our RP can reach to it, right? Now, I understand that can be challenged with some organizations where they don't want any inbound, outbound connectivity from their network. That is a problem, something we are looking to address. I'm happy to kind of talk about that offline with you. Question?
Is it recommended to run HBase and Kafka and like Spark on the same cluster, or should you create different clusters for each one of those services?
Great question. So the question is, why do we have like so many different cluster types, and why don't we put everything on like on a same cluster? So if you look at our Spark cluster, it has a Hive, Hadoop, Uzi, Scoop, everything in it, right? Everything that runs under Yarn is part of that cluster. The challenge with something like HBase and Kafka is that they do not run under Yarn, all right? And so the resource governance becomes a challenge. And if you think about these applications, both HBase and Kafka, they run pretty hot from like a CPU and memory perspective. And if they're constrained, you could say that, hey, in Yarn would only take 50% of the node capacity, and rest of the 50% is non-Yarn, so that means you can run maybe Kafka and HBase. But that is very static in nature, right? That's not dynamic in nature. So you may not be able to use the Yarn-based application to sort of a maximum. And moreover, these are quite a complicated workloads like HBase, and what we have seen is that if they run like a standalone, they tend to have very less production problems and things of that nature. So that's why we made that decision. Now we may revisit that in future, given Yarn is much more sophisticated now. We can have a node labels, for example, and you could do some interesting things like that. But I think where the things are right now, having some of these non-Yarn based workloads separate is probably the best for like a production type workloads. Yeah.
Another question. Do you see any performance penalties from like data lake storage v2 doesn't have like the data locality as HDFS does? Is there a big performance issue with that?
That's a subjective. I'm sure there'll be use cases where it might be, but what we have seen, you have a very high bandwidth with the underlying store. So in terms of your ability to get data from underlying storage has been never been greater, so it's actually faster. The other penalty that you could potentially see is in terms of the shuffle, which is again network related, and that hasn't changed in any significant way. So I don't know like what the implication would be, but maybe if you want to talk more detail about your scenario, we can talk about that.
Are you guys looking anywhere to offer like managed HBase?
Managed HBase. We already do managed cluster service. No, we don't have any immediate plan of doing sort of a managed HBase. Again, HBase is also used in many different ways by our customers. I think people use HBase because they get a NoSQL store at very fast performing NoSQL store that they could customize based on that use case. And I think that's the biggest value that HBase provides to our customers. If there is a managed HBase option that you're seeking, it's not a HBase, but the Cosmos DB would be probably the best choice in that case. But we don't have any intention of building like just a HBase APIs, for example, in a fully PaaS fashion.
On HDInsight, are you planning on offering feature to pause the cluster down rather than spin it down completely and spin it up again?
So the question is, hey, in HDInsight, you create a cluster and then you drop it, right? There is no pause. This has been a very popular, a lot of requests from customers in terms of doing this feature. I think what we are struggling with it is, just from a business model perspective and a technical design perspective, how would it work? So like you said pause. So as a customer, you click that button, say pause, right? What does it mean? Because I'm still being billed by Azure Compute for my VMs or networking resources and so on and so forth. And if I give them away, my IP addresses will be different, DNS name will be different, all of these pieces. So there are, we want to do it. It's just been challenging from that perspective.
I mean, the thing is because Databricks offers you for a cluster rather than tearing it down completely and trying to build it up again?
Yeah, so I think, so I guess the way we are thinking about that, and I shouldn't be revealing, this stream is going everywhere, so we shouldn't be revealing much, but we are looking, so the way we want to kind of address that problem is by making sure that all of the configuration that you have in the cluster, we can capture it somewhere. So because that's one of the, and bring cluster up much more faster than what we can do right now. Thereby, we would meet your need, but the implementation would be slightly different. But happy to chat more offline there. Mm-hmm.
Just now when you talked about the security bit,
Mm-hmm.
about how the
ADDS and Active Directory, or
I'm interested in the part where the security, the access control goes down to the storage layer.
mm-hmm.
Is that only applicable for if you're using the ADLS Gen 2 with hierarchical namespace, or can you also get that functionality with Blob?
Not with Blob. So we would push this identity all the way to underlying store, right? ADLS Gen 1, ADLS Gen 2, Blob store. But Blob store itself doesn't have an enforcing mechanism. So it can't do anything with the identity that we have passed to them. So to answer your question, no, with Blob store, it does, you can't restrict at the store level. With ADLS Gen 2, you can. With Gen 1, you can, although Gen 1 will not recommend. Mm-hmm.
Yeah, similar to the questions about ADLS Gen 2. So the problem we have is that we, after compute data is stored in ADLS, it creates this like massive, deep folder structures. So it's no problem with the system, but whenever we hire somebody new, we have to like generate, give them permission for that person or that groups. And it takes forever to like go in each of the files and folder. Is that common, or how do I?
And you're talking about the ADLS Gen 1 or Gen 2?
We are on Gen 1, but
Yeah.
I'm looking at your slide. Gen 2 also have ACL on the file and folders level, right? I would assume it's still 10.
I don't know the specific use case, but you as a child, you inherit permission from your parent, right? So whatever permission that you set there gets propagated, unless you want to kind of assign some very specific permission, to a very specific folder. So that's the workflow that I'm aware of in ADLS Gen 2. If there is a different workflow that you're talking about, I would, And then there is all the booths are closed. The ADLS Gen 2 team was down there in Expo Hall. Maybe I'll give you their contact detail, and you can talk to them directly.
Yeah, I think our problem is that adding the permission after the data has been generated.
Yeah.
It doesn't happen very often, but it's kind of annoying.
Yeah, I know.
To that question, right? I mean, I think ADLS Gen 2 has a limitation in terms of the actors that can be provisioned, both on Gen 1 and Gen 2. So it's 64 approximately, I think 32 for default and 32 for another category of actors
Mhm.
on Gen 2. So I mean, assuming if you're trying to do security, not RBAC, but security using actors, then I'm guessing you'll run into that same issue for HDInsight as well.
Yeah.
So I don't know if I've spoken to the Gen 2 guys. They don't have anything in the roadmap to address that. I don't know how HDInsight by itself.
Now you and I will together, be after them. You have one more friend here. All right. Good deal? One more.
So Azure Data Box also has Spark cluster. What do you recommend for each different scenario versus HDInsight?
Yeah, that's a great question, and I work for HDInsight, and so of course my answer would be biased. So typically, what we have seen, if customers are only using Spark, I think Databricks is a great choice. However, if customers pipeline requires so many of these different specialized technologies, they tend to pick HDInsight. Also, there is a question about proprietary Spark versus open source Spark, and some customers have a preference towards remain open source, so that they can run it on-prem, any cloud, any way they want. So that is other consideration, at least the way customers sort of think about it. But again, yeah, there is a level of overlap in the sense that we also offer Spark as part of our portfolio. All right, good deal. Have a, thanks for coming to Build. I hope it was good use of your time. And are you going to the party tonight? All right, good deal. All right, thanks. Thank you.